and basically education reform for the
Great.
state.
Awesome.
Well, thank you for joining us, everybody. I'll get us started with our quick little intro. For those who don't know me, my name is Katie. I'm the past president of FMSEA, and I am the conference chair for this year, which means, of course, I have to push the conference. So those of you who haven't registered yet, you can do that online on our website at fmsea.org, or any of our social media channels have it. I'll also put the link in the chat box in case you need it. And another little tidbit is you can buy a conference t-shirt. It's actually what I'm wearing right now. It came in, you can see it, it's super comfy, definitely recommend it. But this is our final session of our virtual PD series for the year before we dive into the conference. So I'm super excited to introduce our speaker. But just a couple of things before we get started. Feel free to use the chat feature if you have any questions throughout the presentation. Type them in at any time. I'll leave it up to Annalisa if you'd like to answer as you go or at the end. Whatever you want is totally fine, but throw questions out there as much as you'd like. And the session is being recorded, so if you don't want to be recorded, you can turn your camera off. But of course, we encourage you to keep your camera on if you're up to being recorded so everyone can see everyone's lovely faces. So without further ado, I'm happy to introduce Annalisa from Florida International University's Case Education Outreach Team. She's got a presentation for you about Mission Inspire, so feel free to take it away.
Awesome. All right, guys. Well, hello, my name is Annalisa. I'm really excited to be here because I love participating in FMSEA events and conferences and presentations. So this is really fun for me, talking to people who have students, who have classrooms, that work with the general public. It's always really interesting to learn from and hear from. So as we go through the presentation, please just ask questions. There's only six or seven of us here, so I'm fine with asking questions as we go through the presentation. And I'm going to give you guys a little overview of what Mission Inspire and what Xpedition Ocean is. So I'm going to make you guys a little bit smaller so I can see. Okay, so Mission Inspire is a subscription-based curriculum that focuses on research done at Florida International University. Within Mission Inspire, we have two expeditions that both of them actually focus on marine science and environmental sciences. And they use research done at FIU to teach students about these concepts. We use real data sets, we use scientific papers, we use lots of information from our scientists to teach students about what is happening in our oceans in the real world. So the expedition that we're going to be talking about today is Xpedition Ocean. So Mission Inspire is kind of like the overarching branch or name of the curriculum. And then within Mission Inspire, there are different expeditions that have a different focus point. So for Xpedition Ocean, the focus point is Aquarius Reef Base, which we will talk a little bit about. It's a really, really cool facility that FIU has. It's an underwater research laboratory, and lots of science goes on there. So we have put together 13 standard aligned lessons that are aligned to Florida Standards of Education, Common Core standards, and Next Generation Science standards to teach students about research done at Aquarius. Within these 13 lessons, they're separated by 4 modules that each have a different theme. And then part of these lessons, we have teacher training videos, which we'll talk a little bit more about, that are aligned to each lesson. We have PowerPoints for each lesson, supplemental resources such as YouTube videos, scientific papers, news articles, and free resources that you can find online that are aligned to each lesson. And then we also have take it up a notch sections, which are for those more advanced or upper high school students. So all the lessons within Xpedition Ocean and Mission Inspire in general are for 6th grade through 12th grade. The next expedition that we have is Expedition Biscayne Bay. I'm not sure if any of you are familiar with Biscayne Bay, but it is right, Miami is right on Biscayne Bay. We have the bay on one side and the Atlantic Ocean on the other. And it's not doing too great. It's seeing lots of problems. We had a major fish kill in August. There was thousands and thousands of dead fish just on our shores, and it's having some real problems. So we decided to do an expedition on Biscayne Bay, and it does focus on this bay, but it covers concepts that can be covered, around the nation. If you live near a body of water, these lessons will most likely apply to your local ecosystem. And they go over water quality, ecosystem services, mangroves, marine debris, and wildlife. But today we are talking about Xpedition Ocean and Aquarius Reef Base. So just a brief overview about what this is. It's also my background. And it's a really, really cool facility in the Florida Keys National Marine Sanctuary on a reef called Conch Reef. And it's the world's only underwater research laboratory. So scientists go here to conduct their research, to do studies, whether it be someone studying coral recruitment or coral bleaching, ocean acidification. We've had studies on predator-prey relationships, on herbivorous fish behavior, on marine protected area usage of specific species. So there's lots of different types of research that can go on at Aquarius. And it's a really unique resource, and it allows us, or scientists, to spend a significant amount of time underwater. And we'll get into that in a little bit, because one of our modules covers scuba diving basics. And this facility has been in the same footprint since 1993. So it's been on this reef in the Florida Keys since 1993. Before that, it was in St. Croix. It was built in 1987. So it is getting up there in years. And, we did have some issues with Hurricane Irma coming through. Something that our operations guys always say is, when you have one of something, it takes a lot longer to find the one-of-a-kind pieces that your one of something needs. So when there are hurricanes or things like that, it does take us longer to get back up because we are one of a kind. But within the past 30 years, FIU acquired this facility in 2012. So before that, it was part of UNCW, University of North Carolina, Wilmington, and then before that, NOAA. And so in the past 30 years, there has been 151 saturation missions. We'll talk about what that means, saturation diving, in a little bit. And so that equals to 1,255 days spent living underwater, which is, I think, pretty cool. Okay, so does anyone have any questions about Aquarius before we jump into some of the modules and lessons that we have? No, okay, that's fine. Okay, so the first module that we have within Xpedition Ocean is called Living and Working Undersea. And this one really kind of sets the stage for what Aquarius is and its uses and why it's so important. It does cover diving and pressure laws and gives students experiments to do that teach them about pressure and volume. Within the lessons, we are hitting standards for middle school math and then physical science and nature of science standards in Florida. So all of these standards that I'm going to be talking about today are Florida. Again, they do align to NGSS and Common Core as well, but for this presentation, we're going to stick with Florida. If you've ever worked with multiple standards before, it's a doozy. So bear with me as we run through them. So that module 1, we have a lesson called Mayday, which I use it as an overview for Aquarius. Let's say you choose to only do one lesson within Xpedition Ocean. I always say start with Mayday and then go to your other lesson just to give your students an overview of Aquarius. It puts them in an emergency situation at Aquarius and they need to decide what tools they need to survive for 3 days without any outside support. So, how are they going to maintain a safe atmosphere? How are they going to address any first aid issues, or what if they need to leave the facility? What if they need to leave the habitat? So It gets them thinking about being at Aquarius and being in the field. Lesson 2 under pressure covers Boyle's law, and it talks about the inverse relationship of pressure and volume. So if you fill up a balloon at depth and you release it, it's going to expand because there's less pressure, therefore more volume. So there's lots of examples like that within under pressure. There's also lots of middle school math. So that's a lesson that we're gonna get into now and do one of those problems together. And then dive in covers Henry's law. And that one really helps us learn more about dive planning and doing dive tables together. I have worked with a marine science teacher, a 6th grade, actually she did middle school, and she said these lessons were a little too hard for her 6th graders, but the concepts she used to talk about scuba diving and then moved on to the next module. So under pressure, this is our Boyle's law. And it's funny that I chose this because a little tidbit or behind the scenes of Xpedition Ocean, Boyle's law is not my favorite, but for some reason, it follows me everywhere. Every time a teacher has a question, it's about Boyle's law. Every time I have to do a video, it's about Boyle's law. So Boyle's law really likes me, but I don't like it. So this is our question within the lesson. I just chose one question that the students are looking at. So Aquarius sits at 60 feet. So use the absolute pressure formula to calculate the absolute pressure at this depth. So it's important to know as a scuba diver, how much pressure is being exerted on your body, right? So the absolute pressure is going to tell you the total pressure that you're under at a certain depth. So using this formula, if you guys want to do it, you can, but you need to convert feet to meters. So you're going to get about 18.2 meters. And your answer is going to be 2.8 pressures per square inch. So Aquarius sits at about 2.8 PSI. So what makes it so unique is that while divers are at Aquarius, or while scientists are at Aquarius, they are saturated with nitrogen. So they are saturation diving. So that means that nitrogen and these high pressure gases are saturated in their tissues. And if they were to just ascend to Aquarius, to the surface without doing any kind of serious decompression, they would get decompression sickness and need to go in a hyperbaric chamber like immediately. And so the reason that scientists live at Aquarius is that now that they're saturated after 24 hours living at Aquarius, that's their new normal, per se. And so living at 60 feet, being under 2.8 pressure per square inch, they can now dive to 90 feet for a significant amount of time per day. It's about 6 to 8 hours per day they can go down to 90 feet. So that's a real advantage for scientists that need to set up an experiment, that need to collect a lot of data. They are in the water for long days and they do get very cold. You wouldn't think that they get cold in the Florida Keys, but it's deep and it's cold after being in the water for so long. So it's a really great resource if you need to go to depths and collect or set up experiments for long periods of time. And so this lesson kind of goes over that and goes over pressure and the amount of pressure on your body as you're scuba diving. Any questions on Boyle's law or on module 1? Cool. Okay. So the next module I would say is my favorite. It has a wide range of topics and it covers, it starts with corals. And we talk about plant and animal cells through using corals. Then we go into talking about asexual and sexual reproduction, again, using corals and coral recruitment. And then talking about classification of wildlife using fish and other reef organisms. And then we go into the protection of natural resources, focusing on marine protected areas. And throughout this module, it's really great for middle school math and then middle and high school nature of science and life science. Like I said, that first choral lesson, Choral Creations, students, there's a whole, game where students pretend that the whole classroom is an animal cell, and each group of students have their own duty to perform as an organelle within a cell, and they need to perform their duty to keep the cell moving. So that's a really fun interactive game to play. They go into learning about corals and how they're animals, coral anatomy, and they make a model of a coral, learning about the different parts. Then we move into where in the world is my coral larvae? If anyone knows Carmen Sandiego, that is where that name came from. And this one is really cool. It talks about coral recruitment and how long it takes coral larvae to recruit onto a reef after spawning events. So this one we use to talk about sexual and asexual reproduction within organisms, and then in specifically corals. Fish Detective, again, talks about classification of wildlife and different characteristics and adaptations of fish. And then Connect to Protect is that marine protected area lesson where we use a study done at Aquarius to talk about the uses of marine protected areas, stakeholders, and along with it, there's a field game and a in-class activity where everyone is a different stakeholder, and we kind of work together to create our regulations for our marine protected area. The lesson that we are going to touch on within this one is where in the world is my coral larvae? So within this one, students are given various materials and resources to help them answer these questions. They're giving some data charts, they're given a scenario, they're given a map of ocean currents, and then a range map, so a map of just where their coral would be. And they need to use these resources to answer the questions provided, and as well draw a map of how far their coral larvae traveled after spawning. So we're going to do one together. This is, I'll give you your scenario, but I'll just read the question. Plot the route your larvae took. Place an X where your coral began and an X where it recruited. Based on the data, how long do you think it was between spawning and coral recruitment for your coral? So for this one, we were given a moon coral. That is our example. They are a broadcast spawner, and they spawned in Eastern Australia off the coast of Sydney. They were a larvae for 195 days and traveled 100 kilometers. So students also need to look at the ocean currents of the location where their coral spawned to see maybe which direction their coral larvae went in. This is so that they kind of understand there's so many different factors involved and so many things going on for these coral larvae that determine where they go. It's really interesting looking into the research on this. Many corals do recruit on their own reefs. So when they spawn, the larvae will recruit on a reef nearby, but some of them travel pretty far, which is interesting as well. So our coral started, oh, Dita's here. Our coral started right here off the coast of Sydney, and your students can use the little rulers on the bottom of each map to determine how far their coral went. This one went 100 kilometers, so they didn't go too far, and that is where they recruited. So again, this is just to help students visualize, understand that larvae are free floating, they're in the water column, they're subject to ocean currents, pushing them here or there to weather. So it's a really great activity to kind of help students visualize what's going on when a coral spawns, and then the larvae, what happens to the larvae before it recruits. Any questions on module 2, which, like I said, is my favorite? Okay, awesome, not a problem. We will move on to module 3, Seas of Change. So this is also a really interesting module. It covers carbon dioxide and greenhouse gases, human-induced greenhouse gas emissions, environmental parameters, and human activity, and how we're impacting the environment, and in turn impacting our oceans and our marine organisms, specifically corals. In this module, the lessons are covering Earth and space science, life science, and nature of science, and then we also have middle school math standards covered within these lessons. So we have a lesson on coral bleaching called Can You Take the Heat? For this lesson, students are looking at coral bleaching data in the Florida Keys and on the Great Barrier Reef, and they are doing comparisons to bleaching events. That one is really fun. It has a pretty large data set to use, and then it also asks students, each student will have a different question that they need to answer based on the data. So it helps students determine what information is useful for what they're trying to answer, and what information maybe isn't so useful for their specific question. So that's really important for these grade levels, looking at what's important, what I need to know, what's extra information that really doesn't answer my question, and so on. Then we have more acidity, more problems, which goes over atmospheric CO2. We look at data from the Mauna Loa Observatory in Hawaii, and we look at atmospheric carbon dioxide levels throughout, I think we start in 1980 and then look at from 1980 to 2020. And we talk about how the ocean is absorbing CO2 and the amount of CO2 the ocean is absorbing each year. This one has a lot of math, a lot of percent increase, percent decrease, but it's a really fun lesson, and I really enjoy doing it as well. The last one is SOS Rising Seas. So this one is students create a model based on a real coastal city. They use data from NOAA to looking at sea level rise in different coastal cities around the world, and they create a model of this city and looking at sea level rise in these cities. And we also explore solutions. So for all of these lessons, we talk about the threat, but we also explore solutions locally, on the individual level and on the global level. So what is being done and what can be done, because those are really important questions for students to be thinking about. So for more acidity, more problems, we're going to do a quick question together. So for this one, you know, we learned in the lesson that we didn't do together, but that the students did. The ocean absorbs 35 to about 40% of carbon dioxide in the atmosphere. For this activity, we're going to assume that it absorbs 35%. Calculate how much carbon the ocean absorbed in 2010. Your answer should be in parts per million. So students are given this graph, and this is what helps them answer these questions. And this is updated daily. So you can also go onto this website with your students and look at the daily atmospheric CO2, which is really cool. You can compare it, you know, it could be a whole year-long project to compare how the atmospheric CO2 changes throughout your school year. So for this question, in 2010, there was 390 parts per million of atmospheric CO2. So really what we did, I mean, this isn't 100% accurate, obviously, but for your students, it's a great way to conceptualize how the ocean absorbs CO2, and that, you know, the human-induced greenhouse gas emissions that are happening impacts the ocean. The more CO2 in the atmosphere, the more the ocean will absorb, right? So all it really is multiplying 390 times 0.35, and you get 136.5 parts per million absorbed in 2010. And then I did it again in 2020 just so that you can see the difference. In 2020, it was 410 parts per million of atmospheric CO2. And so we got 143.5. Also in this lesson, students are asked to project the atmospheric CO2 in 2100 based on the percent increase each decade from 1980 to 2020, and then to project to 2100, and then again to see how much CO2 the ocean absorbed by 2100. So it's a really great modeling exercise for your students. And our last module is called Space Prep. So something I haven't mentioned yet, because I was waiting to get to this part. NASA uses Aquarius to simulate being at the International Space Station. So every year we have astronauts at Aquarius preparing to go into space. They practice things like spacewalks. They practice things for example, last summer, they practiced using this machine called a LESA, L-E-E-S-A, and it helps astronauts who have fallen to get up because they can't bend their knees in their suits. So if they're like on their backs and they can't get up, and then their fellow astronaut can't go down to pick them up, they have this machine that they put under the astronaut and kind of lifts them up like this. So it's a really interesting tool that they were practicing to use last summer, or maybe 2 summers ago, because COVID and hurricanes. So yeah, 2 summers ago. And so they do some really cool things. And they also incorporate doing marine science. So they were learning about coral recruitment. They made a coral tree last time they were at Aquarius in collaboration with Coral Restoration Foundation to make a coral nursery at Aquarius, which is really cool. And so these lessons talk about these sea to space connections, simulating weightlessness, simulating spacewalks, and then students they carry out experiments to look at these connections. And this module also has a writing lab. We're trying to make these lessons cross-curricular. They all hit English language arts standards. And if any of you teach in Florida, you will know that English language arts is changing their standards for 2021, 2022, which is really fun for curriculum writers, like awesome. So we went through and made sure that everything is updated and aligned to the new, it's called Florida's Best Standards, BEST as an acronym. But so the writing lab definitely is our lesson that hits the most writing standards. So within this module, we have design an AUV. So this is a really fun model activity where students make their own underwater vehicle, autonomous underwater vehicle. It's really fun. You can practice with it, like in a bathtub or in a pool or in a lake. And we talk about how the astronauts and now aquanauts use AUVs at Aquarius when practicing to be in space. And then we have a buoyancy lesson that talks about simulating weightlessness and using weights at underwater to simulate zero gravity. And then the best analog is our lesson that is a writing lab. It also covers information on our planets, on atmospheric differences within our planets, because I know that that's some standards for physical science. So it does go over those concepts and then brings it back down to Aquarius. So for buoyancy to sea to space, we can't do this together, but what's really fun is we have a ping pong ball that we pretend is our astronaut, and we place the ping pong ball in water and he floats. And we need to make our ping pong ball or our astronaut neutrally buoyant in the water. And we do that by adding coins to our ping pong ball. We tape them on, so using pennies, dimes, nickels to make your ping pong ball neutrally buoyant and to simulate weightlessness. There is a lot of trial and error with this activity. You're going to be taking off coins, taking off a penny, adding a dime, taking off a quarter, adding a nickel, trying to make that ping pong ball neutrally buoyant. And that's a really fun activity to teach students about what it means to be neutrally buoyant. And so that is our brief overview on Xpedition Ocean. Does anyone have any questions on the lessons or on the modules, on our writing process? All of these things are, this is kind of like my baby. So I can answer any questions and any feedback again as well, because it's always changing and always growing and always improving. And if not, we can keep going.
I saw Laura had a question about how do you access the modules?
Yes, great question. And we will get, I mean, we can talk about that now. So it's in the PowerPoint, but we could just go for it. So this is a subscription-based product, right? So the way that it is being done currently is administrators purchase the program for the school or for specific classes. We are working with grants and sponsorships to get this in schools in specific counties, because I know not all administrations are interested in fee-based curriculum, but that is our model, and we are working with counties and sponsorships and grants to get these in schools. We also have, as I go, you'll see we have a professional development workshop aligned to these lessons, aligned to these expeditions. And within those, we have a package that makes it a lot cheaper to do the professional development and then get all of the modules and all of the expeditions. So there's different options. And if you're interested in having it in your school and in your classroom, please reach out, because we can, like I said, work together on those sponsorships or find ways to get that for you, okay? Definitely, like I said, I understand a teacher might not have the funds to do this, a school might not have the funds, a district might not have the funds, but we are very interested in working together to get that into schools. So with each lesson, we have a teacher training video. So these I think are really fun, because you get a lesson plan that you've never done before. You know what the concept is, but you're kind of like, oh, I don't have a lot of time. I can't read all this right now. Each lesson has its own 5 to 10 minute video that kind of just gives you a brief overview of what you should be talking about, some points to hit, and what the activity is. And so I put together a brief little video on Dive In, which is one of the lessons in Module 1. And I chose this one. You'll see why I chose this one. It's pretty funny. But this is just what you'll be seeing. First is remove the lid from the soda bottle, seal the opening with the balloon and duct tape, and shake the bottle and set it down. So let's see what happens. So students should hypothesize that the balloon inflates because when the bottle is shaken, the CO2 or carbon dioxide molecules that were dissolved in the liquid increases the solubility of the CO2, creating bubbles. For in-depth instructions, background information, and supplemental resources, please refer to your digital portal. Thanks, and see you later. So it's obviously not the whole video, that's just like pieces put together. But after that soda sprayed all over the studio, they were not happy and everything was sticky. But that's what happens when you're doing science with kids or almost 30-year-old adult. So these, I really enjoy these. I think they're a great resource, a really quick how-to guide, and each lesson has its own. Then we also have our PowerPoints that you can use in your class. They go over all the topics that you need to hit. They are aligned to standards, each PowerPoint. At the end of each PowerPoint, we have a standard connection slide that just makes sure that you're hitting those standards, right? So for example, this one right here is for Fish Detective, which is talking about classification systems. So these are the high school standards that we're hitting, and these are the concepts that you need to be discussing or bringing up with your students, so that you know that you're hitting that standard. I really enjoy these, honestly, because my boyfriend used to be a teacher, and he said if he had an administrator coming in, he always had the standard on the board so that it was, very adamant that this is what they're learning today. So I already did that for you. It's already on the board, and this is what you're learning today. And then we have Take It Up a Notch. So I mentioned this earlier. These are for high school students or advanced students. And they're just little brief, do this instead of this for the educator when reading the lesson plan. And we also have the Aquarius Science PowerPoints. So within lessons, we use scientific articles that were done or written based off of research at Aquarius. And you can either assign the paper to your students to read, which might be pretty advanced, but if you have 11th or 12th grade students that are advanced readers, advanced in science, you can give them the paper to read. And then they can fill out the engineering and design worksheet, answering questions about, what is the question? What is the hypothesis? What were the methods? What was concluded? What would you change in this experiment? So getting them to really think about these scientific papers and these experiments. But if that's too high, which I think it is for most, we have a PowerPoint that runs through the paper and says, okay, these are the questions that the scientists were asking. These are the methods. This is, their conclusions, and you end up doing it together. So that's one way to take it up a notch or bring it down a level depending on your grade level. And then professional development. So we have a program called Camp Create, where teachers participate in a professional development workshop, learning about Mission Inspire. You choose the expedition that you're interested in doing your professional development with, and we help you align the curriculum to your pacing guide. So we look at your pacing guide, we look at what standards you need to hit throughout the year, and we place these lessons throughout your guide, so that when you go back to the classroom, okay, on this week I'm teaching about cells, I can use Choral Creations. The next week when I'm talking about reproduction, I can use Where in the World is My Coral Larvae. So it really depends on what you're teaching. Again, this can be used in math classes, in English classes, and in science classes, just depending on what you're teaching for that week and that year. So again, using your pacing guide for this professional development is key. And it's really fun. So we have different types. We have a virtual one. We have one on our campus. We have one where we go to your campus. And then we also have one down in the Florida Keys at Aquarius, not in Aquarius. Teachers actually snorkel above it. They haven't been able to go inside yet, but we are hoping that is something that we can do soon. But it's a really fun opportunity. And it's a great PD. We also have continuing education units available for these PDs. And then lastly, we have our interactive programs, part of education outreach. So Mission Inspire is a big part of what I do, but we are a bigger team that does other things as well. And we have aligned our other programs to be done in classrooms to Mission Inspire. So this is just a quick little video about that. Or not, it could be. I guess it's not. It's okay, we don't have to watch it. It's just a couple of minutes about our lab programs. Right now they're all done virtually. For example, we did a virtual field trip yesterday. So we were seine netting, and the students were on like an iPhone on a tripod watching us. But then we came in and did identifications, and we measured the fish, and they had data sheets at home that they were filling out. So they are normally done in person, but we've been doing them virtually. And we do have ones like our seine netting one that would align to different lessons within Expedition Ocean. This is exactly what I just talked about. And we have a really quick little sneak peek at Expedition Biscayne Bay. This expedition is really, it's fresh, it's very new. I just finished it, and the writing process was very different than it was for Expedition Ocean. So it's a growing process for me and a learning process for me, as well as, a growing process for our whole team, understanding, what concepts work best with which standards, what NGSS standards are, similar to the Florida standards, and making sure that we're really integrating those, not just you know, brushing the top or the surface of the standard. Like we really want to integrate it and weave it into the lesson so that there is no way that that is missed. So this lesson is called Show Me the Mangroves, and it's on ecosystem services. And we put a price tag on different components within Biscayne Bay. So if all of the mangroves in Biscayne Bay had a price tag, what do you think they would be? If all the seagrass in Biscayne Bay had a price tag, what do you think it would be? And we kind of do an auction. Students have auction cards, and we do an auction on how much we think it's worth. How much is a mangrove forest worth to me? You know, I don't know. So we talk about that in that lesson. And this is kind of how our auction would go. So these are the price points that we have. If anyone wants to take any guesses as to how much each system or each component of the bay is worth to our local ecosystem, to our local economy. Let's see. But there we go. So mangroves are worth 47 million per year. Seagrass, 471 million per year. The lagoon, which is the middle part of Biscayne Bay, 771 million per year, and recreation 2 billion per year. So looking at these numbers, like this is an important resource, and it's important. I mean, if we care about money, right, which I'm sure many people do, we need to start caring about our natural resources, because this is boosting our economy and making it giving jobs and providing for many people in South Florida. And so this question was asked already. How to get mission inspired in your classroom using grants and sponsorships. If you do have funding, that's great. Definitely reach out to me if you're interested. But again, reach out to me if you're interested, even if you don't have funding, because like I said, we can try to find that for you. We are in the process of doing that. And then again, we have that professional development package for 15 teachers. That includes the PD, Camp Create, the curriculum, and Meet the Expert for your kids. And that's at a discounted rate. And that all can be found on our website. Which I spelled wrong here, but that's okay. I'll put it in the chat. And then I also have a quick little questionnaire, which I'll also put in the chat, just so that I can understand, where you guys are coming from, what you're looking for, and how we can help each other. So let me stop share. And if anyone has any other questions, I'd be happy to answer those.
And Nesty said he did in the chat. If you'd like to come off mute, you're welcome to.
Hey, can you hear me okay? Can you hear me okay?
You're very quiet.
Yeah, but I know you're there. Hi.
Let me reconnect.
It almost sounds like you're in a tunnel. Do you want to try the chat box? We can try to answer it that way.
That is the questionnaire while he's typing. And then you can find us or more information about PACE, Education Outreach, and Mission Inspire here. For similar age groups, no, but that is definitely something that we would like to expand on. So within the next years, we have the Xpedition Everglades in the works and Xpedition Miami. So those are going to be older grades as well, but I think after we get those all 5 expeditions out, then we'll start to work on younger grades. We also have the interactive programs. So the labs and field trips, those are catered to younger kids as well as older kids. Yay.
Hey, can you guys hear me better now?
Much better.
Okay. So I'm good friends with Roger Garcia, the DSO there, and I've been in touch with him recently about potentially leading an overnight expedition with some of the members of our organization, Diversity in Aquatics, that gets marginalized people more connected with ocean exploration and marine science. And so he had mentioned during the expedition that we would put together that we would be doing some live outreach events and whatnot. So I think you covered this maybe a little bit already, but in the modules for the curriculum, would there be opportunities as they come up to be able to have students connect with those live outreach broadcasts directly from the habitat?
Yeah, so that's something that we haven't done recently. You know, there hasn't been many missions because of COVID. And then before that, there was Irma. But before both of those things, we were doing virtual field trips with the aquanauts in the habitat. Let's see how I can answer this. As the time has progressed, the model for that has been changing. So yes, it is an opportunity, but the model for it isn't going to be the same. So in the past, it was the aquanauts underwater. Let's get all of these people to talk to them, right? So I had people all over the world tuning in at different times. Just like I had like a 12 o'clock, a 4 o'clock, a 3 o'clock, just lots of different outreaches going on, and it was a lot. So I think what we're going to do moving forward for those is make them smaller and have them be fee-based. But again, that would be separate from what you were planning to do with Roger. But this is just in the future for when we continue to do outreaches with the aquanauts. Cool.
That
Yeah,
everybody?
awesome. Thank you. Yeah, so to be clear, then it would be, like you said, a fee service outside of the curriculum itself.
Yeah.
As they come up. Okay.
Yeah.
Thank you.
Mm-hmm.
Excellent. Well, if that's everybody's questions, I suppose we can wrap it up. Thank you so much for presenting. I am personally no longer an educator, but